Namaskar everyone. In the last lecture we had studied about acids and bases, and now we know what are acids, what are bases, even we know what are neutralization reaction. Every time in this reaction there is a formation of salt and water with the release of heat energy. Now in this class we will study what are salts. Starting with the definition, a salt is an ionic compound that results from the neutralization reaction between an acid and a base. Like for example, the common example we have taken, when hydrochloric acid reacts with sodium hydroxide, it gives you sodium chloride plus water with the release of energy. Now over here, sodium chloride is nothing but the common salt, and which is a ionic compound. So what are ionic compounds? Ionic compounds are actually made up of ions. That means when they are dissolved in water, they dissociate or break down to form separate ions, like cation, the positive ion, and the anion, the negative ion. So if I dissolve sodium chloride in water, what I'll be getting? I'll be getting a cation, sodium ion, and an anion, that is the chloride ion. Clear? So we can conclude that sodium chloride is an ionic compound. Now moving on to the next part, preparation of salts. There are several various methods for the preparation of salts. Few will be studying. The very first, we have already discussed this, when acid reacts with the base. First example, like when sodium hydroxide reacts with sulfuric acid, what we get? We get a salt plus water with the release of heat energy. Now the salt, how the salt has formed? The salt has formed, like it has, if you will see, it has a positive cation and the negative, the anion. Okay, the positive part is taken from the base, sodium hydroxide, and the negative part of salt has been taken from the sulfuric acid, that is the sulfate, isn't it? And thus the salt has formed. Similarly, the second example, if we will take ammonium hydroxide, when reacts with hydrochloric acid, it forms a salt plus water with the release of heat energy. Now the salt, again it is an ionic compound which consists of two ions, the ammonium cation and the chloride anion. Now how this has formed? The positive part has come from the base, the ammonium hydroxide, and the negative part has come from the acid, that is hydrochloric acid, isn't it? Okay, coming on to the next part, reacting acid with a metal. This again we have seen, whenever metal like calcium reacts with acid, that is carbonic acid, it gives you a salt with the release of hydrogen gas. And over here, salt, how does the salt has formed? When this calcium metal reacts with acid, what it actually does, it replaces the hydrogen from the acid for the formation of that salt. And the name of the salt is calcium carbonate, which contains positive part as calcium and negative part as the carbonate radical. Clear with this? Coming on to the third type, that is reacting vegetable oil with caustic soda or sodium hydroxide, or we can also take caustic potash, that is potassium hydroxide. So now what do you mean by vegetable oil? It's nothing but a simple cooking oil which we use in the kitchen. It can be your sunflower oil, groundnut oil, anything. Now instead of oil, you can even take animal fat, like vanaspati ghee you can take. Okay, so when the oil or the animal fat, when reacts with sodium hydroxide, we get a soap as a product. And we know the soap is used for cleaning purpose. Okay, so now over here, we will first look onto the activity where we will see how the soap formation takes place. So here is the video for the saponification process where the soap is formed. Let's look onto the video.
Saponification, the process of making soap. We require measuring cylinders, common salt, glass beakers, coconut oil, 20% NaOH solution, Bunsen burner, funnel. Measure 25 ml coconut oil into a measuring cylinder. Pour the oil into a glass beaker. Take another measuring cylinder and measure 30 ml 20% NaOH solution into it. Pour it into the beaker containing coconut oil. Stir the mixture vigorously using a glass rod. Touch the beaker from outside. It will be observed that the beaker is warm. This is due to the exothermic reaction between vegetable oil, that is coconut oil, and sodium hydroxide solution. Place the beaker on a Bunsen burner and heat it until the mixture becomes a whitish paste. The mixture is made up of soap in suspension form and glycerol. Remove the beaker from the flame and allow it to cool. Dip a red litmus paper in the suspension formed. When dipped in the suspension, red litmus paper changes to blue color. This shows that the soap solution is basic in nature. Dip a blue litmus paper in the suspension. The color of blue litmus paper remains the same. This shows that soap suspension is not acidic in nature. Add 15 grams of common salt into the suspension. Stir it well with a glass rod. It is observed that the soap is precipitated out as a solid. Take a filter paper and fix it in a filter funnel and hold a glass rod over the funnel. Take the beaker containing soap and pour it over the glass rod and filter the mixture. Soap is left on the filter paper. Take a filter paper and remove soap from the funnel using a spatula and place it on the filter paper. Dry the soap by pressing it with another filter paper. Cut it into the desired shape with a knife. Soap is thus prepared.
So in the video, we have seen how the soap was formed. The process of soap making is called as saponification. Okay. And in this particular process, we need to remember following points. Like for example, what are soaps? We know soaps are basically sodium or potassium salts of long chain fatty acids. Okay. And it was an exothermic reaction. In the video also we have seen when the reaction was taking place between vegetable oil and the caustic soda, the reaction was exothermic. The conical flask has become hot. Clear with this? The heat was given out. Therefore, the reaction is exothermic. The third thing that now in the process we have added salt in the suspension mixture. Why we have added? Just to separate out the soap. And this process is called as salting out of soap. Now, when salt is added to separate the soap from the suspension mixture, soap will get separate. As it is lighter, it will be out on the top of the solution. It will separate out on the top of the solution. And now we can give the reaction, the word reaction, like when oil reacts with sodium hydroxide, it will form soap plus glycerine. Clear with this, everyone? Now moving on to your next part, the naming salts. Now, how to name any particular salt? For example, I have NaCl. First of all, you need to predict that from where this NaCl salt has formed, from which particular base and acid is been formed. So we can predict like the sodium metal is contributed by sodium hydroxide, which is a base, and the Cl part is been contributed by the acid, that is, it can be hydrochloric acid. Okay, thus we can say the name of the salt is sodium, comes from the sodium hydroxide, and chloride comes from the hydrochloric acid. Thus the name is sodium chloride. So we can simply say that the name of a salt is derived from the name of a metal contributed by the base and the radical contributed by the acid. Let's take the another example, Na2SO4. Now from which particular base and acid this salt has got formed? Sodium. It can be sodium hydroxide. It can come from sodium hydroxide. And sulfate, it can come from sulfuric acid, because sulfuric acid also has a sulfate group, isn't it? Okay, so the name is sodium sulfate. Sodium contributed by sodium hydroxide and sulfate group contributed by the sulfuric acid. Next example, CaCO3. Now again we need to predict the first part. Now if you will notice, every time the first part, which is a positive part, it comes from a base. So please do remember, the first part, the positive part, will come from your base, and the second part, which is the negative part, will come from the acid. Clear with this? So in this example also, calcium comes from a base, that is calcium hydroxide, and carbonate comes from the carbonic acid, because it has a carbonate group in the particular formula, isn't it? So what will be the name? The name will be calcium carbonate. Now moving on to some exceptions. We know that ammonium hydroxide is the only base which has a radical and not a metal. So again, over here, when this particular positive cation will be contributed, it will be as a radical and not as a metal cation. Clear with this? So in this example, NH4Cl, the ammonium, which is a positive part, it comes from the ammonium hydroxide, that is the ammonium radical, okay, will come from ammonium hydroxide, which is a base, and chloride ion will be contributed by the acid, which is hydrochloric acid. So we can name it as ammonium chloride. Next example, it's the similar one where we have seen for calcium. Okay, so this potassium K is also a metal. So it can come from which base? It can come from potassium hydroxide. Whereas this second part, which is the negative part, nitrate, it can come from which acid? It can come from nitric acid, as this nitric acid has a nitrate group, isn't it? Okay, so now we can name this particular salt as potassium nitrate. Now last example, which you need to keep it in your mind every time. See, this is CH3COONA. Okay, now this blue color line, that is CH3COO, is a negative part over here, and Na is your positive part. Every time wherever we have seen the metal, okay, metal forms a positive part and the remaining part is your negative part. So over here, this CH3COO is your ion, negative ion, called as acetate ion, and it can be contributed by the acid, that is acetic acid, CH3COH. Okay. Sodium It can come from sodium hydroxide. Clear with this? So your name for this, see, the naming trend will be remaining same. Every time you need to start with the positive part. So my positive part is sodium in this particular salt. Okay. So sodium acetate. The next will be the negative. Clear with this? So name is sodium acetate. Thank you very much. In the next part, we will study about the uses of different salts.